Welcome to today's episode of Tech Talk, where we delve deep into the world of technology, innovation, and what's on the horizon. I'm your host, and today we're diving into an exciting area of artificial intelligence, specifically the advancements in language models, thanks to an intriguing project called llama.cpp. So, let's start with the basics. llama.cpp aims to make large language model inference super accessible and efficient. Think of it as providing a high-performance toolbox for AI developers, but this toolbox is built with pure C++. It's quite fascinating because this means no extra dependencies, like you don't need to install a bunch of other software, just pure, streamlined code. How neat is that? And here's an interesting fact. Apple's silicon isn't left out. The project optimizes performance using Apple's ARM architecture, which really highlights its versatility. They're bringing in cool tech like ARM Neon and Metal for GPUs. For folks using x86 architectures, there's also support for advanced vector extensions, AVX, AVX2, AVX512, and even AMX. What's not to love about such inclusivity in software design? Now you might be wondering, what models can we actually use with llama.cpp? The list is pretty extensive. It supports models like Llama, the Llama 2, Mistral, and even some multilingual models like the Chinese Llama and Vigogne, which caters to French. So whether you're coding in Python, Go, or even Rust, llama.cpp has got bindings ready for you, letting you integrate language models into nearly any environment. Let's think about this for a moment. With such a varied selection of models available, it essentially democratizes access to AI tools. It allows not just developers at large companies, but also independent creators and smaller teams to experiment with cutting-edge technology. Just imagine a game developer pulling in an advanced language model to bring characters to life. How could that change the storytelling landscape in games? It's mind-boggling. Speaking of games, llama.cpp supports some interactive projects too. Features like the Lucy's Labyrinth game enable agents controlled by AI models to engage players in a maze. It's like blending gaming with AI. What a creative frontier. All right, so let's touch on something a bit more technical: quantization and model optimization. It's a way of reducing the size of models while maintaining their performance level. The project uses the gguf file format to store models, which is specifically designed for optimized use with llama.cpp. If you're into AI, you know that size can be a significant bottleneck, so this is a crucial feature. And for our developer listeners out there, the command line tools provided by llama.cpp make it easy to spin up your own AI applications. You can run simple commands to initiate text completions or even set up a local HTTP server to serve your model. Imagine creating your own chatbot with just a few lines of code. Before we wrap up, I want to pose a thought-provoking question. What do you think could be the next big step in making AI language models even more accessible? Could decentralized development become a trend, or will we see new platforms rise to the challenge of making these powerful tools manageable for the average coder? As we close today's episode, let's remember that projects like llama.cpp are not just technical feats. They provide a glimpse into a future where intelligence can be harnessed by anyone with an idea and the will to create. Thank you for joining me on this exploration of llama.cpp and its incredible potential in the realm of AI. If you enjoyed this discussion, be sure to subscribe for more insightful conversations about technology and innovation. Until next time, keep dreaming big and coding boldly.